Hi there, welcome to my channel Maths SL. I'm speaking Thaqib Latif. This is the last question, question number 10. The question says in the diagram below, P, A, E, R, and S are points on the circumference of the circle with center O. DSP is a tangent to the circle at S. DSB at S. AOWS and RWP are straight lines. So there we go. PR parallel to BS. There we go. So this is the information of the sketch. Prove with the reasons the following. 10.1. PW is equal to WR. So first of all, we need to identify a relevant information. We are given PA, E, R, and S are points on the circumference of the circle with center O. P, A, E, R, S. This is the center O. DSB. DSB is a tangent to the circle at S. AOWS. AOWS and RWP. RWP are straight lines, and PR, which is this one, PR, parallel to BS. So don't forget this one, PR parallel to BS. So these two lines are parallel. So the first question we need to prove PW, this PW is equal to WR. So we need to prove this one. So as I can see, WST is going to be a 90 degree tan perpendicular to radius. So this angle is going to be a 90 degree tan perpendicular to radius because this is the tangent. Now W1 is going to be a 90 degree. Why? Because co-interior angle. If these two lines are parallel and then this is 90 degree and W1 also 90 degree, because co-interior angle add up to 180 degree. So if this is 90, so the W1 gonna be a 90 degree. There we go. This is 90 degree. This is also 90 degree. Therefore, I can say now PW is equal to WR, because if you look this way, W2 is gonna be also 90 degree angles on straight line. So line from center perpendicular to chord. So that's why PW is equal to WR. So the WSD is equal to 90 degree tan perpendicular to radius. W1 is equal to 90 degree co-interior angles PR parallel to BS. PW is equal to WR. Line from center perpendicular to chord. 10.2. Triangle APS similar to triangle RWS. Now, second question is quite interesting. We need to prove. He already give you this. These two triangles are similar. We need to prove. So we're gonna say in triangle, the first triangle, APS, and so in triangle APS and triangle RWS, we need to prove actually two things, and the third angle gonna be a sum of angles of triangle, or you can say third angle of triangle. So we need to prove these two triangles are similar. So first of all, we need to first A gonna go with R. That's easy. So the yellow one APS and the orange one is RWS. So the angle A is gonna go with R, so the R2. So which means this angle here, angle A must go with angle R2. So we need to prove this one. So have a look here. Angle A is first go back, touch the point P, and then go back, touch the point S. So the PS, this is the chord. And what other angle forming this chord? Have a look here, R2. So angle in the same segment. So angle A is going to be equal to R2, angle in the same segment. Therefore, angle A is equal to angle R2, angles in the same segment. Now the P gonna go with the W. In this triangle, have a look here. This is the diameter. This is gonna be angle in the same semicircle. P1 plus P2 plus P3. So APS, this angle gonna be 90 degree angle in the semicircle. And the W1 on this triangle already 90 degree. So they are equal. So this is my second angle I proved. So the angle P is going to be equal to angle W1 90 degree, angle in the semicircle. So the last one now. So the S gonna go with the S. So only left now S2. So angle S2 gonna be equal to angle S3, third angle of triangle. So angle S2 is equal to angle S3, third angle of triangle, or you can say sum of angles in triangle. So therefore, now I proved, so triangle APS similar to triangle RWS. Reason is angle, angle, angle. They we proved. 10.3 RS square is equal to WS multiply AS. Now the last question is quite interesting. We need to use the similarity from 10.2. So we already proved that the two triangles are similar. So we need to write the ratio of corresponding sides. Since the triangles are similar, the ratio of corresponding sides is equal. So, so the AP over RW is equal to the last two PS over last two WS is equal to first and the last AS over first and the last RS. Now, why we say this one? Because similar triangles. We must give the reason. Now, now we need to prove that RS square is equal to WS multiply AS. So the WS and AS in these two ratio. So we're going to use these two ratio. Now, so cross multiply PS multiply RS. PS multiply RS is equal to and WS multiply AS. WS multiply AS. So you can say AS multiply WS, doesn't matter. So now we need to prove that RS square is equal to WS multiply AS. So the right hand side is fine, but the left hand side we need to replace PS with RS. So we need to think out of the box here. Normally these type of question I always taught my learners that you must use the proportionality theorem or similarity theorem. Now in this case proportionality theorem I can't use. In this case proportionality theorem not gonna work. Only similarity theorem can work. But this is a PS. So I can easy way I can don't need to even use the similarity. There's another method easy that these two lines are parallel, right? Remember the proportionality theorem you're using when the lines are parallel. So now I can use these two lines are parallel, so I can use uh, the fun. So I can use parallel lines. This is the transversal line, and these two lines are parallel. So the angle P3 is going to be equal to angle S1, alternative angle. And the angle S1, because this is a tan and this is the chord PS, and angle between tan and chord, and tan chord theorem, have a look here. This is the chord and forming another angle, alternative angle. This is going to be angle 2, angle R2. So the PS chord forming an angle in alternative segment, have a look here, this R2. So tan chord theorem. So therefore angle S1 is going to be equal to R2. So if this is the case, then angle P3 is equal to angle R2, and if both angles are equal, so side opposite equal angles, so then these both sides are equal. PS is going to be equal to SR. So and then I can replace PS with SR. So angle S1 is going to be equal to angle P3, while alternative angles, uh, because P are parallel to BS, right? And angle S1 gonna be equal to R2 as well. Angle R2, the reason is tan chord theorem. So tan chord theorem. So now both S1 is equal to angle P3, angle S1 also as well equal to angle R2, both angle equal to same thing. So therefore I can say angle P3 is equal to angle R2. Angle P3 is equal to angle R2. Right. Now I can say the PS is equal to RS. The reason is sides opposite equal angles. This is the reason. Essentially is triangle. So now PS is equal to RS. So the angle S1 equal to angle P3, alternative angle. These two lines are parallel. This is transversal line. And angle S1 is going to be equal to angle R2, tan chord theorem, because this is a tan, this is a chord, angle between tan and chord. So this is S1. So this angle equal to angle R2, tan chord theorem. Now in these two angles they are equal, isosceles triangle, sides opposite equal angles. So then therefore this PS is going to be equal to RS. Now this PS I can replace with RS now. So it's going to be RS multiply RS is equal to WS multiply AS. So you multiply RS square is equal to, uh, you can say AS first, and then WS, same thing, or WS time AS, doesn't matter. So the WS multiply AS. So they we proved. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.